8th grade, Mountain Math, Week 2, Number 8. Is it a function? If no, explain. If yes, is it linear or nonlinear? So I'll go ahead and move my face. How about to right here? And if it is linear, we need to find the rate of change in the initial value. All right, so we have a table. They gave us a table for this one, giving us 3 points. And in order to decide whether this is a function, I think the easiest way is to graph this. So I also have included a coordinate plane here. And I'm going to plot these 3 points. So I see there's a point right here, 0, 0. I have a point 1, 5, and I have the point 2, 10. So this is an x, y form, coordinate pairs. So I have a point at 0, 0. I get another color so it's a little easier to read. How about red? So I point at 0, 0. I have a point at 1, 5. So my 1 is over here. If positive moves to the right, negative is left. Negative is down, positive is up. So on my x, I'm going over to 1 to the right, and then I'm going up 5. 1, 2, 3, 4, 5. Point right here. My next point is 2, 10. 2, 10. Double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we need to decide, is this linear? Well, let's check. I can put my ruler here, and I want to see if these all do line up. It looks like they do. So yes, it is linear. So we need to decide, okay, is this a function? Definition of a function. In x and y form, all x's have only one y. So if I wanted to ruin this function and make it not a function anymore, I might have another point at 1, 6. So I have an x of 1 and another x of 1, okay? And this function rule here will not be true anymore because this value of 1 has 2 y's. 1 is 5 and 6. So if this was 1, 6, or if there was a 2, 5, 2, 6, if we had a duplicate in the x that wasn't the same thing in the y, this would no longer be a function. And what that would look like is I would have 1, 6. I would have another point right here where I'm drawing this little x, this little square. I'll make it a little square right here. I'd have another point at 1, 6. And then if I had a vertical line that went through here, if you watch my vertical line test video, we actually cross on this x value 2 times. That would not be a function. However, for this example, that doesn't exist. All of our x's do only have 1 y. So this is true. This is a function. So when it says if no, explain, we don't need to on this one. But if yes, we need to decide, is it linear or nonlinear? Linear means it's a line. Nonlinear means it's not a line. So this is a function. This is linear. We can see that it is a straight line when we connect these points. We need to find the rate of change in the initial value. So the rate of change, also known as slope, or m, and we need to find the initial value, also known as the y-intercept. All right, let me get green because I got quite a bit of writing on my page now. So my slope is calculated as rise over run. We need to find out how far up or down it goes and how far left and right it goes. So starting here, we'll start at this point and we'll go to this point. We'll find out, what is our rise? Our rise is up 1, 2, 3, 4, 5. And our run is just 1. So our rate of change is 5. Our initial value is where does this line cross the y-axis, which is this vertical line here in the middle. It crosses at 0. So the initial value is nothing. So this might be a graph that says for every sandwich you sell, you make $5. So this would be sandwiches, and this is money. So like we sell 0 sandwiches, we make $0. We sell 1 sandwich, we make $5. We sell 2 sandwiches, we make $10. We sell a half of a sandwich, we might get $2.50 because that's up 1, 2 and a half. We might make $2.50 if we sold a half. We might make $2.50, $2.50 for a half of a sandwich. This is a lot like what we've had in class just this at the beginning of the year here. These are called proportions. We know this is proportional. It's a straight line that goes through the origin. So this is proportional, and all proportional relationships have an initial value of 0 if it's proportional. We can see right there, 0, 0 is our initial value. It is proportional. So did we answer all the questions? Let's see. Is it a function? Yes, it's a function. Is it linear or nonlinear? It is linear. If it's linear, find the rate of change in the initial value. Well, we found the rate of change. It was 5, and our initial value was 0.